So welcome guys, I'm back with another set of final question of principle of mathematical induction, and I think that this will cover most of the probable types and principle of mathematical induction. It is not of that important weightage, but I have just taken three different set of examples and following the same basic steps, three steps, to show you that this is quite simple, and if you will follow the steps, so you will arrive at the generalized result what is asked in the question. Okay, so let me take the third set of final example in PMI. Okay, so this is 3 into 5 power 2n plus 1 plus 2 power 3n plus 1 is divisible by 17 for all values of n belongs to n. Okay, so this is a question based on divisibility. Okay, so step 1 is your verification procedure. What is your LHS? Your LHS is for n is equal to 1. So 3 into 5 power 2 into 1 is 2 plus 1 plus 2 into 3 into 1 plus 1, so it is 4. So this is basically 3 into 5 cube is 125 plus 2 power 4 is 16. This is your 375 plus 16 is 391, and if you'll see, it is divisible by 17 because 17 2 is 34 and 51, so 23. Yes, since no remainder is there, your 391 is divisible by 17, so LHS, which was 391, is equated to RHS. That means it is divisible by 17. According to question we have to go now. So we have verified that for n is equal to 1, this thing is verified. Now step 2 is your assumption. Okay, so 3 into 5 power 2k plus 1 plus 2 into 3k plus 1 is divisible by 17. Okay, now if I want to write this statement, this part of statement in mathematical form, what I will write, that this thing is equal to 17 into something, 17 into m. Okay, where m is a natural number. Okay, this thing is equal to 17 into something. Okay, because it is divisible by 17, so definitely 17 will be a 17 will be a factor of that, so 17 into something. Okay, now step 3 is utilizing this assumption to obtain the final generalization. Okay, now 3 into 5 power 2k plus 1, 2 into k plus 1, so that is 2k plus 2 plus 1, so that is 2k plus 3 plus 2 into power 3k plus 4. Okay, k plus 1, so 3 into k plus 1 is 3k plus 3 plus 1, so 3k plus 4. So this is your 3 into 5 power, we can write this as 2k plus 1 into 5 square. A power m into a power is a power m plus n. So 5 into 2k plus 1 into 5 square is same as 5 power 2k plus 3 plus 2 into 3k plus 4 is there, no? So you can write this as, yeah, you write this as this only. Now what is my intention of writing like this? My intention is I have to utilize this result. So for utilizing this result, I have to obtain this set of thing in this also. Okay, then only I can utilize this, na? This result 79. So your 3 into 5 square is how much? 75. And what is your, okay, not 75. Okay, I will consider this 5 square as separate. 5 square is your 25. And your 3 into 5 power 2k plus 1 is what? See, you can write it as 17m minus 2 power 3k plus 1. You can write this as, by transposing this to here, you can write this thing as 17m minus this. So same thing is there. So you can write it as 17m minus 2 power 3k plus 1 plus 2 into 3, 2 power 3k plus 4. Okay. Now what we will do, okay, I'm erasing the above two parts. Okay, so this is like, yes, 25 into 17m minus 2 power 3k plus 1 plus 2 power 3k plus 4. Okay, okay, now you have to analyze this thing. What manipulation you have to do here to make it as 17 into something, then only we'll show that yes, for k plus 1, for n is equal to k plus 1 also, this thing, this set is divisible by 17. So finally we have to arrive at something which is equal to 17 into something. Okay, so this is like 25 into 17m minus 2 into 3k plus 1 into 25, plus we can write this as 3k plus 1 2 cube, that is 8. You understood this? 2 cube, so 2 power 3 k plus 1. Okay, now what we can do here, we can take, okay, we can write 17m into 25, and we can take 2 power 3k plus 1 common. So what we'll get? We'll get 8 minus 25. Okay, so now 17m into 25 plus 2 power 3k plus 1, and this is actually minus 17. So you, if you will take 17 common, you will get 25m minus 2 power 3k plus 1, and this is our manipulated answer, what we actually wanted. See, we get 17 is into something, 17 into q. Okay, this q can be anything, q can be any natural number. Okay, or integer, it can be any integer. Okay, so we arrived at 17 into something. It means that yes, for n is equal to k plus 1 also, the given set is divisible by 17. So by following those three steps only, we and by further manipulation, like what we have to see, that what we assume, that result, if you want to use, you don't want to, you have to utilize that result in your final generalized step, then only you will be able to show that yes, it is generalized for k, it is generalized for k plus 1 also, and hence it is generalized for all values of n belongs to n. So this is the purpose of principle of mathematical induction. You can generalize anything in maths based on the given constraints. Thank you.